8.7, number 8, and it says, consider this function. So we're going to make use a graph to explain visually why g is not differentiable at x equals 0. So I want to talk about graphing that function. First of all, it's kind of like y equals the square root of x, which I hope you realize that's like y squared equals x if you square both sides. And that's a parabola that's on its side, because instead of x squared equals y, it's y squared equals x, so the y and x are changing rules. So it looks something like this. At 1, it's 1. At 4, it's 2. But it doesn't give negative answers. A square root, you have to go plus or minus to get negative answers, so we don't get this bottom half. So that's what part of this looks like. It looks like it goes through 1, 1, and 4, 2. But then if we put negatives in the square root, we get imaginary. But if we put them inside the absolute value first, they become positive, and we can do the square root. So the square root of -1, absolute value of -1, is the square root of 1, which is 1. And if we put in -4, the absolute value is 4. Square root of 4 is 2. We get this other mirror-like half of a parabola. And you can see that there is a cusp. So why is it not differentiable? Cusp. Use the limit definition. Okay, do you remember the limit definition of the derivative? So that was the limit as h approaches 0. And we're supposed to be doing this for g prime of 0. So a is 0. So we're supposed to do g of a plus h minus g of a over h. So that would be the limit as h approaches 0. G of a plus h, well, that would be 0 plus h into the function, which was this. So we're going to get square root of 0 plus absolute value of 0 plus h, which is just h, minus g of 0, and if we put 0 in there, absolute value is 0, square root of that is 0, so we get minus 0 over h. And we have got what they asked us to do. Show that that's the derivative. Now investigate g prime of 0 by estimating the limit using your calculator. So we're going to go get close to that on our calculator. I'm going to pull out the calculator. We're going to go in there. Let's get it over here where there's less reflection, hopefully. And we're going to go y equals, and clear all this, and we're going to put in the square root of the math number, absolute value of x, divided by x. So replacing h with x's, and then we're going to look where h is really close to 0. So where x's are really close to 0, we'll do that in the table, second table, and here I've already put in stuff close to 0, and it looks like as we get closer and closer to 0 on the positive side, we get closer and closer to 316 and bigger and bigger. So from the positive side, it's going bigger and bigger and bigger and bigger and bigger. And if we go further out, it's probably going to go closer to 0. On the negative side, it starts around -3, but then goes towards -100, negative more. So it goes down this way. which is not like what the book answer was. They had this one up here, but it's not there. It's here and here. So use your graph in A to sketch this. Well, slope is really steep here, big positive, and it gets less and less and less. That's what this is saying. Slope is really steep here and gets less than, it's really steep but negative, and it gets closer and closer to zero. Negative and get closer and closer to zero. So that's what g prime of x looks like.